We're continuing with life science cell biology in a nutshell. We're learning about peroxisomes, an important organelle found in eukaryotes, which contains catalytic enzymes breaking down large molecules such as fatty acids and also converting them, and also alcohol, um, ethanol, etc. Large molecules, breaking them down in uh, reactions such as the glyoxylate reaction and into turning them into sugars, um, via acetyl CoA, etc. So it's important. So so peroxisomes perform oxidative reactions where they use oxygen for the breakdown reactions. So oxygen is used to remove hydrogen atoms from specific organic substrates, which is symbolized by R. And in this oxidative reaction, hydrogen peroxide, H2O2, is produced. These enzymes are contained inside the peroxisomes here in the darker shade inside the organelle. So these catalases or enzymes that are contained in the peroxisomes serve to help with the reaction, generating water. So various substrates are oxidized. Toxic substrates or molecules in the bloodstream are cleared in this way via these peroxidative reactions. These include phenols, formic acid, formaldehyde, and alcohol, as well as big molecules like fatty molecules with fatty acid chains. So where you have excess of H2O2 or hydrogen peroxide, this plus the substrate H2 yields the substrate alone plus water. So this is the peroxidative reaction. Also in beta oxidation, the alkyl chains of fatty acids are shortened 2 carbon atoms at a time, converting the fatty acid to acetyl CoA, then eventually to the acetyl CoA then goes to the cytosol, where they are converted to other molecules and sugars, etc. And beta oxidation only occurs in plants and yeast. It occurs in mammals as well, but in plants and yeast it occurs exclusively in peroxisomes, while in mammals it also occurs in mitochondria, as well as the peroxisomes. These are showing the various alkyl groups. And the nomenclature. In the glyoxylate reaction, that's where you have the fatty acids yielding 2 acetyl-CoAs turned into succinic acid, turned into glucose. This glyoxylate cycle only occurs in plants. So fatty acids are turned into carbohydrates or sugars. So oxygen is used. Carbohydrates are created. Here is showing the example peroxisomes, mitochondria, chloroplast, vacuole in plants, glyoxysomes where the glyoxylate reaction occurs. And so in beta oxidation, alkyl chains of fatty acids are shortened and on the way to making sugars and glucose, etc., and other biosynthetic reactions, like once the fatty acids are broken down. So the various alkyl groups, and so alkyls, they form a homologous series. The simplest series have the general formula of C to the N, H2 to the N plus 1. So the number of carbon atoms determines the name. So 1 through 12 carbon atoms. So meth means 1 carbon, eth is 2, 3 is prop is 3, bute is 4, 5 is pent, hex is 6, hept 7, oct 8, non 9, dec 10, undec 11, and dodec 12. So the groups are called methyl, ethyl, propyl, butyl, pentyl, hexyl, heptyl, octyl, nonyl, decyl, and undecyl, dodecyl. The names are used to name branch chain structures. If there's more than one of the same alkyl group attached to a chain, then the prefixes are used on the alkyl groups to indicate multiples such as di, tri, tetra, etc. In addition, each position on an alkyl chain can be described according to how many other carbon atoms are attached to it. The terms primary, secondary, tertiary, and quaternary refers to a carbon attached to 1, 2, 3, or 4 other carbons respectively. So, an example of alkylation is an important operation in refineries, for example, in the production of high-octane gasoline. Also, alkyl refers to an active ingredient in green algae preventives used for swimming pools. So, the term alkyl includes many possible substitutions with substrate. An acyclic alkyl has the general formula C to the N, H2N plus 1. A cycloalkyl is derived from a cycloalkane by removal of a hydrogen atom from a ring and has the general formula C to the NH2 N minus 1. So, and typically an alkyl is part of a larger molecule. In the structural formula, the symbol R is used to designate a generic, unspecified alkyl group. The smallest alkyl group is the methyl group with the formula CH3, shown here. So in plants where you have glyoxylate cycle, these peroxisomes are referred to as glyoxysomes, where the fatty acids are converted into glucose via acetyl-CoA. This is how carbohydrates are made. So here is shown a long fatty acid chain, for example, and with phosphate, glycerol, backbone, and an ethanolamine head group. Such molecules are used for phospholipids. These molecules are used for insulation of axons of nerve cells. They make up 80 to 90% of the myelin membrane phospholipids of these cells. So this is called a fatty alcohol. So a peroxisome with a paracrystalline core and a tobacco leaf mesophyll cell is shown. Its close association with chloroplasts is thought to facilitate the exchange of materials between these organelles during photorespiration, which is using oxygen to produce CO2, used in sugars and carbohydrates. Peroxisomes in a fat-storing cotyledon cell of a tomato 4 days after germination on the right. We'll continue in the next